Hi Tori, it's Miss Rubel here. I am looking at the table in the student guide. Apparently, Connexus didn't like I made and sent a YouTube video on Screencastify, and I think the file was just too big. I'm not sure. But I'm gonna try to make a video and send it to your dad's phone if that works. If not, we'll figure something out. But I just want to talk about how to fill out Table B, which is the calculation of specific heat. So when you go through the lab online, it has you prepare, for example, aluminum wire, put it in the calorimeter, and you're filling out the mass of the metal, the mass of water, Ti of the metal, which is the initial temperature of the metal, Ti of the water, initial temperature of the water, the temperature at equilibrium, which should be the same, right? Because equilibrium would be when the water and the metal have the same temperature. So with the temperature of the equilibrium. And then there's a little place for you to do calculations. So the change in temperature of water, which should be the equilibrium temperature minus the initial temperature of water, right? It's like if water started at 20 degrees Celsius and it goes to 30 degrees Celsius, you would do 30 minus 20 equals 10 degrees Celsius, right? It's a change in water's temperature. And you're going to do the same thing for the metal, right? So you're going to take the temperature at equilibrium of the metal and subtract the initial temperature of the metal to get this delta T, or change in T, or change in temperature of the metal. So as you're going through and filling out these columns, I think you were okay with this. I think the trouble came, and then the specific heat of water is given. C of water is specific heat of water. I think here is where you're having some trouble with the specific heat of the metal. And if I'm wrong about that, just let me know. But the specific heat of the metal, you're going to use this equation, which I've written right here, just so we can take a closer look at it. And it is not as difficult as it seems. I feel like whenever we see these variables, they can get really intensely intimidating, but don't let it be intimidating for you. Basically, the specific heat of the metal, it's the amount of heat that's going to be required in order to raise the temperature of the metal, 1 gram of the metal, 1 degree Celsius, is going to be equal to negative, and we'll talk about that in a minute, it's very important, but let's look at these. A specific heat of water. Wait, how do I know the specific heat of water? Oh yeah, it's given right here, 4.18, no problem. So I'm going to multiply that by the mass of the water, which should be written, as you go through the lab, should be written in your data sheet. And I'm going to multiply that by the change in the temperature of water, which again, we're going to calculate here. So I'm going to multiply these three numbers on top, and then on the bottom, I'm going to multiply the mass of the metal and the delta T of the metal, or change in temperature of the metal. And again, I'm just pulling those mass of the metal. So I'm going to calculate, for example, aluminum wire's specific heat. The mass of the metal, mass of the aluminum wire, times the delta T of the metal. And again, to get that, I'm just going to take temperature equilibrium minus the initial temperature. So what I'm going to do is I'm going to multiply these three numbers on top. I'm going to multiply the two numbers on the bottom. I'm going to divide the top by the bottom, and my goodness, please do not forget this guy. Then I'm going to put a negative in front of the number. And so that's going to give me a specific heat of the metal. So if I'm going to do this, the first one I'm going to do is the specific heat of the metal of aluminum wire. And of course, I'll write my data point here. Now, whatever I get for my data point, I'm going to use for the next column. Now, notice that you're not going to do anything here. These values that are grayed out on the right, they're just here for you to compare. And what this is giving me is the actual specific heat of these particular items. It's like the actual specific heat of water is 4.18. The actual specific heat of concrete is 0.88. So for the 3 types of metal, lead, steel, and aluminum, that we're using in the lab, we have a calculated number, right? So once we go through this, let's say we do this for aluminum, and we get, and I'm totally making this up, but let's say that we get the specific heat of aluminum based on our calculation, based on the calorimeter that we made, is, let's say 0.87. Now, I just made this number up, but let's say that that is what I got from my calculation. Well, my calculated amount is 0.87, but if when I look at the reference chart, it says the specific heat of aluminum is 0.90. It's close, but it's not exactly the same, right? So what I'm going to do in these 3 boxes in this column is I'm going to calculate the percent error. So how much does my value for specific heat of aluminum differ from the calculated, or how much does the calculated, value differ from the actual? So the way that I do this, and I go back up in the lab, there is a formula. Of course, to get the percent error, I'm going to take 100% times the calculated specific heat of the metal. In my case, for aluminum, that would be 0.87, right? And I'm going to, so percent error equals 100 times, I'm just going to write this like if I'm going to do it, 0.87 minus the known specific heat of the metal. Well, what's the known specific heat of the metal? I look in table C, and it told me that the known specific heat of aluminum was 0.90. And I'm going to take that figure over the known specific heat of the metal. Okay, I'm just going to write 0.90 here. And when I do this calculation, it'll give me my percent error, which if my calculated specific heat was 0.87 and my actual specific heat was 0.90, probably not going to have very much, right, in the way of error. So I'm going to put that percent error into table C here. And if the number's pretty small, then that means I did a good job and my calculated specific heat was close to the actual specific heat. If this number is really big, then it means I maybe made some mistakes. It's no big deal. But that happens too, and we would want to know, because if we were in a lab, for example, we would want to do the experiment again in order to get a more closely observed calculated specific heat. I hope this makes sense. I am happy to go through, like for example, go through aluminum with you, or go through steel with you, or if you want to like if you're writing your calculations, or you want to send me your lab table and let me know if you had any trouble, please do so. I am happy to meet with you on Saturday or on Sunday. This weekend we'll be at the beach, but I have Wi-Fi in my car. I'll have my laptop with me, so I can open up Live Lesson, we can screen share, we can figure it out. Just let me know. I'm gonna send this video, which is now, gosh, I was hoping I could make it quick, but I swear I am long-winded. This video is about 10 minutes long. So take your time, go through it, try to do your calculations, but hopefully your dad can open this on the phone. But we can spend as much time as needed this weekend going through this. I hope you guys are doing well, and I apologize that my initial file didn't make its way to you, or maybe by now it's made its way to you. Maybe there was just some kind of a filter issue. Okay, I look forward to talking to you soon. Thanks so much, Tori and Dad. Thanks.